We're going to go through an example from the book. It reads as follows. A cookie company claims that their cookies have an average of 24 chocolate chips per cookie, so a mean of 24 chocolate chips per cookie. I randomly select 40 cookies. I find that my sample of cookies has a mean of 22.1 chips per cookie and a sample standard deviation of 3.8. I suspect that the cookies actually have less than 24 chips per cookie on average. So part A asks us to go through these numbers that we have in the problem and assign them the appropriate notation. And we should remember that mu, the population mean, is actually an unknown value. We can't look at all the cookies ever made and ever to be made and calculate the average number of chocolate chips in them. But we, in this problem, have been told and assumed an estimated, a guessed value of the population mean of all cookies, and that's 24. So 24 is this assumed population parameter mu. 40 is how many random cookies were sampled, so 40 is the sample size n. 22.1 is the mean of my sample of 40 cookies, so it's the sample mean, x bar. And 3.8 is the standard deviation from my sample, so it's the sample standard deviation, s. Part B asks us to create a simulated distribution of sample statistics for this problem, and then we'll find the probability of getting a sample statistic like our sample statistic or lower. So we need to create a distribution of sample means, which we know will be roughly normally distributed. Right? It's going to be a bunch of little dots, and each dot will be telling us, well, these are the sorts of sample means you would expect to get if it were true that the population mean were 24. So it's going to be centered at around mu equals 24, the population parameter. To do this, we need to go to the Rossmann Chance applet. We select the sampling from a finite population /model/bootstrap link. And then we select the population model link. Now we're in the correct applet. We now need to enter the population mean, mu, which we said was 24. We do not know the population standard deviation, but if we don't know it, it is a good idea to go ahead and use the sample standard deviation. Our sample standard deviation was 3.8. So this is just an estimated value because we don't actually know the true value of sigma. We also do not know the population shape. However, I'm going to leave it as a normally distributed population. The reason for that is that it makes a lot of logical sense that the cookies, number of chips in the cookies would be normally distributed. If the mean, for example, were 24, it makes sense there'd be a lot of chocolate chip cookies that would have 24 chips on average, and there'd be very few that would have much, much higher chips per average, and very few that would have many, many lower chips per average. So a normal distribution actually makes sense for the population. I remember to click Show Sampling Options, and now I enter the sample information. We're going to go ahead and create a distribution of sample statistics that has 100 little sample statistics in it, so it'll have 100 little squares. We enter the sample size, which was 40 cookies in my sample, and then I hit Draw Samples. So here we have our roughly normally distributed distribution. I can now go down here to the Count Samples row. I want to count samples that are like my observed sample or lower. Remember, our observed sample had a sample mean of 22.1 chips per cookie. I'm going to go ahead and count samples that are like that or smaller. So notice we have our distribution of sample statistics here, and it put the vertical line down here at 22.1, which is off of this entire graph. It's so low that it doesn't even show up on the graph. There are 0 sample statistics that are like 22.1 or lower. So it's highly, highly unlikely that if the population mean were 24 chips per cookie, that we would go out and get a sample of 40 cookies and find only 22.1 chips per cookie on average. This would be a highly unusual statistic to get. So what conclusion do we make about this? So I would conclude that I don't believe that there are 24 chips per cookie in the population of all cookies. We got a sample statistic that was significantly lower than 24, which gives strong evidence that there are actually fewer than 24 chips per cookie on average.